Almost half of the world's population lives within 150 kilometers of the ocean, with 123.3 million people living on the coast in the United States alone. However, coastal systems are highly dynamic and constantly in flux. For human-dominated coastlines, processes such as erosion and accretion can be destructive. However, these same processes are vital to coastal and surrounding environments by providing nutrients and cycling resources for fragile dune systems. A beach is technically the land along a large body of water. It is usually composed of sand, shell, and other fine particles that have been weathered by the wind and waves. There are many different types of beaches, and they are generally defined by their wave action and sediment characteristics. Today, we will mainly focus on high-energy, sandy beaches. Sandy beaches have three main areas or zones: the backshore, the foreshore, and the nearshore. The backshore is the area of the beach closest to the dunes. It is generally dry and only submerged during extremely high tides or storms. The foreshore is the area between the high tide and low tide mark. This is the area of the beach that is exposed to the changing tides. Finally, the nearshore is the area between the low tide mark and extends beyond where the waves begin to form. This is the area that is influenced by nearshore currents. Within these zones, there are several important features. Berms are any area of horizontal expansions on a beach that run parallel to shore. They can be in any zone. The wide ones in the foreshore are where you will generally find sunbathers. Berm scarps are areas of the berm that have been eroded away by wave action, leaving steep faces of sand. Racklines are present on some beaches and are composed of dead plant material and seaweeds that have been washed up during the high tide. The algal rackline is an important component of stabilizing beach sand and offers a physical structure for many beach plants to take root. Algal rack is also an important habitat for numerous invertebrates, providing food for many shorebirds. Finally, the swash zone is the area that is immediately impacted by wave action and moves with the tides. This is where the water from breaking waves comes ashore and recedes. One of the most important features of beaches is that they are constantly moving. A principal force on the beach is longshore drift. Have you ever swam in the ocean only to notice that you have drifted far from where you started? If so, you have been affected by longshore currents. The longshore current flows parallel to the coast between the shoreline and where the waves break. The longshore current also influences waves, causing them to break at a slight angle to the shore. This angle is extremely important in transporting sand along the beach. As waves crash onto the shore at an oblique angle, sand, shells, and other particles are also pushed at an angle onto shore. As the wave water recedes, it washes down at an angle perpendicular to the beach, carrying those same particles with it. These actions create a zigzag along the shoreline. This zigzag is known as longshore drift and carries sand sideways along the coast, resulting in a net motion running parallel to the beach. Because sand particles are constantly being washed onto the shore, down again and up, beaches are constantly moving. The effects of longshore drift can drastically change the profile of a beach depending on factors such as the wind and supply of sediment. Longshore drift results in two important processes: erosion and accretion. Erosion is the loss of substrate from the shoreline. Accretion is the deposition of substrate to the shoreline. Because longshore drift results in the movement of sand from one place to another, the shoreline is continually being eroded and accreted. However, these processes may not always be equal, resulting in the net loss or gain of beach sediment. As longshore drift moves up this coastline, sand is going to be transported along the shore. Where there is a change in the coastline, there will also be a change in the longshore drift. In this scenario, sand is being eroded from point A and accreting at point B, Where the coastline changes, there is a loss of energy, resulting in the deposition of sand and the formation of a spit. Although these processes are natural and important to the dynamic nature of coastal ecosystems, they can be problematic for humans when erosion and accretion occur in unwanted areas. Extreme erosion events can lead to the loss of homes, roads, and even the beach itself. Humans have dealt with these problems in varying ways with various ecological consequences. These methods can be divided into two categories: hard engineering techniques and soft engineering techniques. Seawalls are large walls that are placed along a coastline to prevent erosion. Not only are these walls expensive to install, but they are costly to maintain. Strong backwash undercuts the wall, destabilizing it. Anyone who has ever stood in the swash zone has experienced these forces. As you stand in the swash, the sand beneath your feet is displaced as you slowly sink. The same mechanisms are at play with seawalls. Additionally, the effects of erosion are simply directed elsewhere, and erosion is accelerated where the seawalls end. As the shoreline erodes and the beach narrows, there is a disproportionate loss of the back shore. This leads to a decrease in the number of habitat types, resulting in a loss of biodiversity, specifically within faunal macroinvertebrates that are important basal food sources. As distinct zones of the intertidal area are homogenized, there is a loss of algal racklines and a decrease in intertidal organisms. These losses affect trophic cascades, leading to reductions in shorebirds and other important mesopredators. Additional organisms, such as sea turtles, also lose this vital habitat as nesting ground. Constructing groins is another method of hard engineering. Groins are low-lying walls that jut out to sea perpendicular to the shore. Groins work by interrupting longshore currents, thereby limiting the net movement of beach sediment. The beach on the updrift side of the groin is protected and may even grow, but the downdrift side of the groin can experience severe erosion because the sand that would normally be deposited in this area is blocked by the groin, creating a sand deficit. Although the effects of groins are still not as drastic as other hard engineering techniques, the interference with longshore drift still negatively impacts biodiversity. Beach renourishment is an example of a soft engineering approach. Beach nourishment is the addition of sand to an eroding beachfront with the aim of widening the shoreline. Although this approach is generally considered more environmentally friendly, there are many negative consequences that can be exacerbated by factors such as the quality and quantity of sand used for the nourishment, the construction activity and technique, and the timing of the project. As sand is added to the beach, not only is the shoreline widened, but it is also thickened. Although many organisms can survive deposits of sand on the beachfront, heavy deposition can be fatal. Studies have shown that additions in excess of 90 centimeters are deadly for faunal organisms. However, for a nourishment project to be effective, deposits need to be thick. Most nourishment projects deposit anywhere from 1 to 2.5 meters of sand, resulting in a total loss of macro and faunal organisms. Similar to seawalls, extreme losses to the basal food web results in drastic consequences that can cascade up many trophic levels. The quality of sand is also an important factor in beach nourishment projects. The quality refers to things such as grain size, percentage of shell, and overall color. Adding sand to a beach that has different qualities than the native sand can be detrimental and has resulted in decreased species richness and abundance. For example, a change in grain size can result in beach compaction. Birds may have difficulty foraging because their bills are unable to effectively penetrate substrate. Burrowing organisms, such as various arthropods, may also be limited in their movement. Sea turtles have also been deterred from nesting on nourished beaches due to sand compaction after nourishment. Sea turtle nests are important sources of nutrient inputs to an already nutrient-limited system. In a high-density nesting area on the Florida coast, A 20-mile-long stretch of beach was estimated to contain 150,000 pounds of sea turtle eggs. Not all of the eggs will hatch, and not all of the hatchlings will escape from the nest chamber. As these organisms decompose, they provide essential nutrients to the dune systems, resulting in stronger plants and contributing to the overall health of dune ecosystems. Finally, the process of nourishment can be harmful not only to shore ecosystems where sand is deposited, but also offshore where sand is collected, resulting in the disturbance of two distinct habitats. As large, heavy equipment is used to collect, deposit, and distribute sand along coastlines, the beach is turned into a construction zone, full of noxious fumes, foreign chemicals, and lots of noise. Coastal areas are harsh habitats, constantly being restructured by wind and waves. The longshore current is just one of the forces that continually erodes and accretes the beach. The organisms in this ecosystem have adapted to deal with these dynamic conditions. However, their biggest threats are not wind and waves. Humans have tried to prevent coastlines from changing by armoring the shore with walls of concrete, rocks, and sand. These ambitions are not only expensive and impractical, they are also ecologically harmful. In our efforts to prevent change, we have simply delayed and exacerbated it, resulting in massive erosion and accretion events that have unraveled food webs and destroyed critical habitat. The coast will continue to change, and so should we. We need to learn to live with nature, not against it, and develop techniques that will benefit both society and the environment.